Now guys, there is some sound. Now am I audible, guys? Now sound is there? Yeah. I don't know what is happening. You know, there will not be internet, there will not be sound, there will be nothing. Something is totally wrong. Repeat what you have said, repeat all, sir, repeat from the starting. Thank God, thank God, thank God. Karan, Shubham, Prashant, Karan, Prachi, Shubham, Raja. पूरे दिन खराब हो गया. हिंदी में बोलो, हिंदी में क्या बोलना है इधर? This is purely English here. This is not Hindi, this is purely English. Am I visible to you guys? My visibility is there? I don't see myself over there. I am from Andhra Pradesh, Satish. Am I visible, guys? I don't see myself here. Am I visible? Am I visible, guys? Yeah, I am visible, I am visible. It's okay now. So I am visible, I am audible, and I am visible, I am audible, and net is working, everything is working. Fine. So yeah, Narendra, don't get depressed too much here. You constantly keep on saying that, sir, I am depressed, I am depressed. What the hell is that? Why you are depressed? Just because of my class, like, if one class gets postponed, then you will get depressed. You don't have other subjects to read. That's what I am saying constantly. I am very much sorry that my class is getting delayed or it is getting postponed, but that should not be the reason that you are wasting your whole time. Why whole day is wasted? Whole day you are preparing only for transportation engineering. Generally I'll take from morning 7 to 9 there will be transportation engineering. After that, what you will do? After that, whatever you are doing, you should generally do that, right? Fine. That is only for one day, and yesterday there was no class. Then you can utilize that 2 hours for another subject. It's like your mindset. You have to program your mindset. If there is some problems, like if you're going in a path, there will be many hurdles. You should be very much smart enough to cross those hurdles, and then you reach the destination. It's not like there is a hurdle, I am depressed, I'll sit, I'll keep on crying, I'm depressed, I am depressed, I am depressed, I'll cry, I'll cry, I'll cry. Is that how you are going to lead your life? No, right? So if there is some hurdle, you have to cross the hurdle, take it in a proper way, and then reach your destination. There is no question of depression over here, there is no question of wasting of time, and there is no question of anything. Time is very precious. I know that July 18th is your engineering service examination as per the previous schedule. I know that. So that means up to June 18th, at least if you ask me, by June 18th, you should have completed your technical syllabus. From the starting, I was saying that complete your technical syllabus by June 18. Technical means I am dealing only with transportation. I dealt with structures, I am dealing with transportation. You have to read other subjects, right? I don't know who are the other professors that is taking different subjects. So you have to read other subjects properly and keep on practicing it. I am only available for 2 hours in a day. Only 2 hours I am taking. What about the rest 10 hours that of your preparation? That should be constantly moving on. Fine. Okay, I delayed 2 hours today from morning 7 to 9. I was not available, or my class, yesterday my class was not there. Then what you have to do? Either take rest or prepare another subject in that time period and come to me the next day whenever there is a class. Be flexible. So by June 18, let us say in 2 to 3 days, I will complete transportation engineering. Then what will you do? What exactly you are going to do? After that you should complete your syllabus, and from last one month if you ask me, I just prefer people preparing only non-technical subject. Your first paper is very much important from June 18 to July 18. If you ask me, that if you have not prepared earlier, then from June 18 to July 18, what you have to do, you have to prepare only non-technical paper. So that means in your 12 hours of preparation, 8 hours should be non-technical and 4 hours should be technical. That's how things go. So why I am saying these things is, of course, I am sorry that my classes are getting disturbed and I got COVID in between, and then I am getting, if not by last month, mid only, like last May 15th or 16th only, transportation would have got completed. But due to COVID, I was not able to take the classes. It is getting delayed, but that doesn't mean that you'll keep on sitting and crying that transportation is getting delayed. Transportation is just part of ESE. It is not bigger thing of the ESE. There are other 14 subjects in engineering services and other 12 subjects from the first paper, and you have to constantly keep on practicing everything. So once again I am saying, of course I am sorry this is getting delayed. The reasons can be many things, COVID or internet or sound problem or other issues, whatever it is, but that should not affect your preparation. These are hurdles. You have to cross the hurdles and reach the destination. That's how you have to modulate your mindset. Understood, guys? So yeah, I'll start my class today, but I can only say one thing: stay motivated, stay positive. There are even not only this, many hurdles will come. The thing is, you should just cross the hurdles. Why? Because if you take this as a bigger reason in your mind, tomorrow if you don't clear any things, or if you are not successful, you will constantly keep on giving the reasons. Fine. Winners don't give reasons, only losers give reasons. The thing is, winners, what they'll do is, they'll analyze from their mistakes, they'll learn from their mistakes, they'll analyze it, and they'll find another way and they'll go in that way. That's how things work, guys. So if one class or something is happening, don't get deviated by it. That is major problem. Don't get deviated by it. Sir, I am depressed, classes are not going on, like this, like that. No. Everything, at the end of the day, what I'll say, I have completed transportation, then I was not available for 10 days. You can read another subject in that 10 days. I can say that, right? It's not my life, it's not my future that I am talking about here. It's your life, your future. So you have to be clear enough. Okay, fine, this guy is not available for 10 days. Then I have to read, in these 10 days, I have to read another subject. Once this guy comes, he lets us clear this subject and this subject will be cleared. That's how your things, your mindset should be. This last 1-2 months of preparation, thinking, strategy will help you a lot to clear the examination. Whatever you have studied for 9 to 10 months, that is different, and the last 1 or 2 months, that is different. You have to constantly keep on motivated. You have to constantly keep on, positive attitude should be there. Sir, okay, whatever you might have read, suddenly you feel like, I don't remember this formula, I don't remember that formula, I don't remember that concept, I don't remember this concept. This type of fear should not be there. The thing is, then what you have to do is open the book, try to solve the questions. I don't say try to read the formulas, try to solve the questions, and suddenly if you get struck, go and read. Then the concept will be registered in your mind, and once again do previous year's problems. Previous year's problems is very much important here. All the previous year's problems, if you do it for 3 times, 4 times, 5 times, that is far more better to clear engineering services. Okay, so if I am not taking class in the morning, then you should not waste your time in the morning. Either you can rest, sleep for that 2 hours and read in night 2 hours extra. Your body should be very much flexible. You are just 20, 21. So can't you keep your body flexible? If one day your timetable is getting affected, that should not be like that. Tomorrow when you are representing India, like you'll be, when you become engineering services officers, how will you behave? Like suddenly there will be meeting, you will be called at 12 in the night, you will say that 12 p.m. I am sleeping, I will not come. Do you think other country delegates will wait for you? When you are representing India, you should be very much flexible. You should sleep at night 4 o'clock or early morning 4 o'clock. So keep yourself flexible. At the same time, keep motivated. There might be frustration, yeah, even I understand, because even I am having frustration that why these things are happening, internet and all those things. So at the same time, motivation, keeping yourself motivation and moving on is also important. How I feel, like okay, morning I was not able to take the class, I tried for another 1 hour 2 hours, but server is down, so I was like I constantly wait, and I did another works, another my own works, and I completed all the works. And then I came back, I thought of taking the class 7 p.m. I asked the students, they are okay with it, and I took the class. So the thing is, I want to make it happen and made it happen. Okay, if this was also not possible, then tomorrow I might have taken 4 hours of class, 4 hours, 6 hours of marathon and complete it. Simple. So reasons are okay, but analyze that and then be a winner. Don't be a loser. Fine. And I am extremely sorry for delaying your classes, and I mean for cancelling the classes or delaying your classes. I'll make sure that this will not happen in nearby future. Fine. Let's start the class. Good evening guys. Don't worry, don't be sorry and anything. Can I start the class? Shah Wasim, good evening. Yeah, no, it's not sorry and all those things. It's like, see, even I am very much sorry about delaying the class. The thing is, keep yourself motivated, keep yourself positive. You want the job, you want to clear engineering services, then reasons should not come forward. The results should come forward. That's what I say. Change your mindset like this. Keep a positive attitude till the last point of the examination. Like as this Dhoni says that take the game deep. So take the game till the last ball, and then finish it off with a 6. Fine. So that's what I say. And now coming to the concepts. Today I'll be starting railway engineering. Till now we have seen highway engineering. Now we'll be starting railway engineering. We'll be starting railway engineering. So transportation means this is one way of transport, that is highways is the roads. Here railway engineering, what exactly we are going to deal with? Will not be dealing with trains, will not be dealing with trains, locomotives, that is automobile guys concept. What exactly will be dealing is, will be dealing with the rails. Fine, we will be dealing with the rails, sleepers, ballast. The thing is, even in the roads also, in highways also, we are not dealing with the buses and all those things. We are buses, scooters, all those things are that is for mechanical engineering. We are most worried about the thickness, pavement characteristics, design of pavements, whether it is flexible pavement or rigid pavement or traffic control of traffic, what is the type of materials in the pavement. The same thing here also, we are more worried about rails. So if I say this is soil subgrade, on the top of soil subgrade there will be formation. There will be formation means indirectly there will be an embankment. There will be formation, so indirectly there will be an embankment. On the top of the embankment there will be ballast. ballast can be like this, or ballast can be in any way. It's not necessary that it has to be in the form of embankment. It can be of any way. Okay, so this is ballast, and then on the top of the ballast, there will be sleepers. Fine. On the top of the sleepers, there will be rails. Generally we go for flat footed rails. Generally we go for flat footed rails. There will be I sections and there will be flat footed rails. So what these are rails. Generally it will not be straight, it will be provided in the form of slope. Okay, and this is sleepers, and this one is ballast. So sleepers are generally made up of concrete blocks, precast concrete. Generally you prefer recently that we are using. Sleepers can be timber sleepers also, whatever the type of sleepers. This is cross section of the rails. Okay, rail would be like this. I am just showing the cross section. So there will be ballast and there will be formation. Ballast is generally provided. Why ballast is provided? Ballast is provided from for cushioning point of view. Ballast is provided from cushioning point of view. Generally made up of this, this boulders, gravel, all those things will be used for ballast, and below that formation, that means you can provide some soil subgrade or soil or embankment type of thing that you can provide. On the top of it you are going to provide rails, and generally there will be fasteners between the rails and that means it is fixed to the sleepers. This is fasteners, fine. So and then this distance between the inner face to inner face of rails, the distance between inner face to inner face of rails or running face is also called as gauge distance. This is also called as gauge distance. Fine. Ballast is, why ballast is provided? Ballast is provided for cushioning effect. Like when you go and sit on your bed, there will be some cushioning effect. On sofa there will be cushioning effect. So when train comes on, sits on us, there should be some cushioning effect. So that cushioning effect is provided from ballast, and sleepers are provided to hold the rails in the position. Okay. So this is the cross section of the rail, and based upon the gauge distance. So what is gauge distance? Gauge distance. Gauge. It is the distance between. It is the distance between inner face. It is the distance between inner face, or you can also say inner face of the rails. It is the distance between inner face of the rails, inner face, or I can also say running face of the rails. Running face of the rails. Based upon the gauge distance, the track is divided into several types. First one is broad gauge. So the gauge distance in meters, 1.676 meters. Broad gauge, BG, that is generally given as BG. Next one is meter gauge. MG. The distance is generally 1.0 meters. This is generally, sometimes you see that broad gauge distance can also be 1.7 meters, 75 meters also, but in general I am saying, okay, this is 1.676, this is 1 meters, and narrow gauge that equals to 0.762 meters, standard gauge that is 1.435 meters. This is standard gauge. So these are the different types of gauges, and then gauge distance in meters. Fine. So the track is divided into different types based upon the types of gauge and gauge distance. Types of gauge and gauge distance. 1.676 meters, 1 meter, 0.762 meters, 1.435 meters. So any doubts? There are even more different types of gauges, but majorly that was used in the examination. That is what I have given over here. So any doubts in this, you can ask me up to here. Thank you Rahul Gupta. Hello Deep. सर पेपर पोस्टपोन होने से फ्रस्ट्रेशन हो रही है. पेपर पोस्टपोन हो गया. Which paper? I think Dande sir is fighting for postponement of the paper, but there is no proper announcement. I think there is no proper announcement. I think, right? Anusha Manchojula, good evening. There is no proper announcement till now, I think. Fine. So these are different types of gauges. Even you can add one more thing, light gauge. So light gauge will be generally 0.610 meters. So this is light gauge. Different types of gauges. Light gauge. Based upon the gauge distances, it is classified into these types. If nothing is mentioned in the question, you have to take these values. Okay. Next one. Next is coning of the wheels. Coning of the wheels. Generally, the wheels will not be perfectly cylindrical. It will be coned. That means wheels would be wheels will be in the shape of cones, where diameter near the flange is more compared to diameter at the other. This is flange, diameter near the flange is more and diameter at the other end is less. Similarly, fine. So this is like coning of wheels. Your track will also be provided in the same slope. The slope is generally 1 in 20. Fine. So this is flange, this is also flange. Running face, that means this face, that's what I said, the running face is the face where flange is near to the rails. The face which is near to the flange is called as running face. This is running face, this is running face. So distance between the running face is called as gauge. Fine. So generally this is how you are going to provide the rails. Okay. So diameter over here would be D1. Diameter over here would be D1 and diameter over here would be D2. D1 and D2. Sir, why? Why we are providing coning of the wheels? Why can't we provide the straight horizontal wheels like this? Fine. So, and then there will be a rod. This is the axle, right? This is the axle. This is the axle. First thing is two things. Okay. The simple way of explanation, if I take a curved track, how generally the curved track would be? Generally the curved track would be like this. Curved track would be like this. There will be one track, there will be another rail over here. This distance is the gauge distance, right? This distance is the gauge distance. Now if you see the distance traveled by, if this is the radius r, this is theta, the distance traveled by this would be more. I mean, I can write this as some, if I take this as some radius r, let us say, on a curved track, this is on a curved track, this would be r plus g times theta and this would be r times theta. So the distance traveled on the inner rail is less compared to that of distance traveled on the outer rail. You have to design in such a way that the distance traveled on the inner rail is less, distance traveled on the outer rail is more. So what happens is, when this is moving on a curved track, when train is moving on a curved track, there will be centrifugal force. Whenever there is a movement on the curved track, there will be centrifugal force that will be acting outwards. Centrifugal force will be acting outwards, right? So if centrifugal force is acting outwards, what happens is the wheels goes like this. If the wheels goes like this, then what happens? This smaller diameter D1 comes here, this larger diameter, smaller diameter D2 comes in the inner rail, larger diameter D1 goes on the outer rail. That means it moves like this. So if it moves like this, D2 comes on this like this and D1 moves out like this, right? So D2 comes on it like this and D1 of this one will move out. That means outer rail, the diameter of the wheel on the outer rail would be D1, diameter of the wheel on the inner rail would be D2. D1 is more than D2, right? So if D1 is more than D2, then distance traveled by this, distance traveled on the outer rail is more than distance traveled on the inner rail. Distance traveled, if you ask me indirectly, perimeter, so pi D1 will be more than pi D2, right? So that means this satisfies this. The distance traveled on the outer rail should be more than distance traveled on the inner rail. When you are seeing in the plan, when it is going on the curved track, when your wheel is going on the curved track, the distance traveled on the outer rail should be more than distance traveled on the inner rail. This is satisfied only if we provide coned wheels. If we provide straight wheels, then what happens is it will not move. That means when it is going like this, the diameter on both the things will be same and then it gets stuck over there only. Fine. That is the reason. Coning of wheels, majorly it is provided for keeping curved track in the mind. That means the distance traveled on the outer track should be more than distance traveled on inner track. That is the reason coning of wheels is generally done. So distance traveled on auto track is more than distance. This is satisfied. The major part of this is satisfied by coning of the wheels, and some part of this is satisfied by skidding and slipping. Okay. So that is what happens in the curved track. And on the straight track, straight track what happens is, straight track, what exactly happens? What exactly happens on the straight track, if you ask me? So on the straight track what happens is, rigidity of the wheel comes into the picture. The vehicle is going like this. Let us say your train is going like this. There will be movement in the trains, right? So if there is movement in the trains, what happens exactly is, the diameter of the contact, let us say the diameter of the contact on this point and at this point should be same. If diameter contact is same, then only it can move straight. Are you getting it? If diameter contact is same, then only it moves straight. If it moves sidewards, that means if train gets sidewards, deflected sidewards, then what happens is, diameter on one rail is more than diameter on other rail. That means this will try to move heavy distance compared to that of this. That means it tries to go like this. When it tries to go like this is not flexible, this is a rigid base or rigid axle. So the rigid axle, what happens is, this tries to pull like this, so it slowly becomes straight, right? So that is the idea. On straight track, in order to avoid derailment, or in order to keep the wheel perfectly at the center, in order to keep the wheel exactly at the center, we are going to do the coning of the wheels. So this is better understood if I show a video for you. It is in YouTube actually. There is a nice video here. Yeah, this video. When you see here, if you are providing a cylindrical thread, that means we are not providing coned wheels over here. We are providing a cylindrical thread. When you provide the cylindrical thread, and if it goes on this, it can't move on the curved path. Can you see? It gets struck over there, and there will be some amount of jam. This is what happens in cylindrical thing. And if you are providing a double coned like this, and if it is flexible, that means if it keeps on moving, if it is flexible, then what happens is, then also it gets derailed. So it gets derailed, it can't move. And finally, if you are providing conical thread with rigid axle means this axle is rigid, and then it is properly fixed, and then this is coned like this. Fine. If it is coned like that, then you can see that if it is moving on a circular track, it gets adjusted itself. It gets adjusted itself like that. Are you getting it? So that means so if you see here, on the outer rail the diameter will be more, on the inner rail diameter would be less. This is and the inner rail diameter would be less, on the outer rail diameter would be more, right? So that it can traverse the path easily. That is the idea. Fine. So any doubts in this? You can ask me. Any doubts in this coning of the wheels? Good evening, Akash. Very high brightness. Any doubts in this? Any doubts, guys? Even the basic doubts are encouraged over here. If you have any doubts, just go ahead and ask. Like, it will move like this. On the curved track, it goes easily like this. On the straight track, it tries to maintain exactly at the center. If it goes like this, because of rigidity of the axle, it comes back to its original position. If it goes like this, it comes back to its original position. If it goes like this, it comes back to its original position, so that it will be perfectly straight. That is the idea of coning of the wheels. It takes more amount of time to explain this, but sometimes, very rarely, the questions are asked. But anyway, any doubts in this, you can ask me. Any doubts in this, you can ask me. Clear? Fine. So coning of the wheels, coning of the wheels, coning of wheels is provided, coning of wheels is provided, so that coning of wheels is provided, so that, or I can directly write, first of all I will try to explain what exactly is coning of the wheels. The wheels provided, for trains is generally in the shape of cone, The wheels provided for trains is generally in the shape of the cone. With maximum diameter, at the flanges, and minimum dia at the other ends, purpose on straight track on straight tracks, the dia at the contact will be same. Dia at the contact will be same. On straight tracks it is provided so that diameter at the contact will be same. That means if it is dx, this will also be dx. Diameter at the contact will be same so that wheels would be exactly at the center, or train will be exactly at the center. There will not be any derailment. Fine. On straight track, in order to avoid derailment of train, and make sure that wheels are exactly at center. We make sure that wheels are exactly at the center. How it is done? This is done by maintaining same dia at the contact of train and rails, and also due to the rigidity of the axle, This is the first purpose on the straight track. And then on curved track, the major purposes in order to make sure that distance traveled on outer track is more than distance traveled on outer track is more than distance traveled on inner track. Distance traveled on outer track is more than distance traveled on inner track. How it is done? This is done by coning of the wheels. This is done by having higher diameters on the outer wheel, and smaller diameters on the inner wheel. On the inner wheel means on the contact of inner wheel. Okay, smaller dia on the outer wheel, and smaller dia on the inner wheel and larger dia at the outer wheel. When it is moving like this, on the outer wheel there will there will be larger diameter, on the inner wheel there will be smaller diameter. And there are other purposes also, that it avoids wear and tear of the rails. Wear and tear means rubbing effect would be very less. If you provide cylindrical tread, the area of contact will be more, so wear and tear would be more, whereas here the rubbing effect would be less. Fine. So, and only a part of this is satisfied by this providing different radius diameters. The other part will be satisfied by the skid and slip. Fine. So these are the major purpose of the coning of the wheels. You can take a note point, another note point also here. It is provided It is provided in order to reduce wear and tear of rails and wheels. Fine. Any doubts in this? You can ask me. Rahul Gupta, rail slope. Rail slope is same as that of cone slope. Rail slope is the same as that of cone slope, and generally what is the cone slope? Slope is 1 in 20. Rail slope is also 1 in 20. Fine. This slope is also 1 in 20 and this slope is also 1 in 20. Any doubts? Any doubts, guys? Any doubts, guys? No doubts? Fine. So this is coning of the wheels. Next one is long welded rails. Long welded rails. LWR. Long welded rails, short welded rails. What are these things? From exam point of view, I am discussing only one thing, that is long welded rails. Generally, what is the length of the rail? Length of the rail would be approximately 12.8 meters, 13 meters. Generally available length is 13 meters. 13 meters is not this much. This is 1 meter. So 13 pieces of this, like 13 meters. One rail is available in 13 meters, but your track will be for kilometers and kilometers. Right? Your track would be for kilometers and kilometers. So generally what you will do is you will join one rail with the another rail, one rail with the another rail. So when you are joining joints, that joints are the weakest points. Weakest point means when load is applied at the joints, there can be failure. So we have to make sure that there will not be any failure at the joints. So what we do is we generally weld it properly. Proper welding is done at the joint so that both the things will act like a single unit. Both the rails will act like a single unit. So joints we generally try to avoid by welding it. Fine. So long welded rails. Long welded rails are provided for track of long length. Long welded rails are provided for track of long length. So that is long welded rails. Generally rails are available for a length of 12.8 meters. Generally rails are available for a length of 12.8 meters. 12.8 meters. So for preparation of track, rails are joined. Joined by welding it properly. Rails are joined by welding it properly, as joints are weakest points. As joints are weakest points, those are welded properly. And long welded rails are provided for long welded rails are provided for longer lengths. Long welded rails are provided for longer lengths. And if there is joint, then because of increase in temperature, there will be temperature effects, right? In rigid pavement also we have provided some expansion joint, contraction joint. Why expansion joint is provided? If there is change in temperature, so it can expand or contract, right? But here the expansion joints or contraction joints, that gaps should not be provided, because rails are not allowed to expand or contract. They are welded properly. There will not be any gap between rail and rail. They are welded properly. So that means no expansion is provided. If no expansion is provided, then stresses are developed. So the temperature stresses or stresses developed due to temperature is generally taken by sleepers. Fasteners. The fasteners will be connected to the sleepers, so generally taken by sleepers. So sufficient amount of sleepers is to be provided, so that there will not be any stresses. Are you getting it? So what exactly I am trying to say is, if let us say this is the track, these are sleepers, long welded rails. Fine, long welded rails. Let us say you are providing long welded rails. Generally, at the central portion of the long welded rails, there will not be much movement. At the central portion of long welded rails, there will be no movement. Why there will not be any movement? Because more amount of sleepers is provided, so there will not be any movement. But at the ends of the long welded rails, there is possibility of expansion. So that length is generally called as breathing length. So sufficient number of sleepers are there is possibility of expansion, because sleepers quantity would be less. So sufficient amount of sleepers it should be provided. Sufficient number of sleepers it should be provided, so that there will not be any expansion in this. L minimum. Fine. This is also L minimum. This is breathing length. Fine. So this is also breathing length. This is also breathing length. Okay. So in the central portion there will not be any movement. In the ends, the possibility of movement is there. That movement is arrested by fasteners or sleepers. So sufficient number of sleepers is provided. To avoid the movement over here. Fine. So if we see here, how exactly we can write over here is, if let us say, if L is the length, on one side of rail, if L is the length on the one side of the rail, then expansion due to change in temperature, expansion due to increase in temperature, delta L is generally given as L alpha delta T, or I can also write delta L upon L equals to alpha times delta T. Here it can't expand. If you remember, I told you in structural analysis, if a member can't expand, then what if you increase the temperature, it tries to go up outwards, but it can't expand because there are fixtures or this is an indeterminate structure, or there is it is fixed at the ends. If it can't expand, then what happens is, what will develop? Stresses will develop. Delta L by L equals to alpha times delta T. This is strain. Strain equals to alpha times delta T. Then stresses will develop in it. The same thing here, the rail can't expand. Why? Because it is fixed. The rails are fixed to the sleepers. Fine. That means stresses will develop. This stresses is taken by the sleepers. So delta L by L equals to alpha delta T. Strain equals to alpha times delta T. Stress upon strain, as per Hooke's law, stress upon strain equals to E. Fine. So from this stress equals to E alpha delta T. Stress equals to stress that should be taken is E alpha delta T. If area of the rails, if cross sectional area of rails equals to A, then force developed P equals to A multiplied with stress that is developed. So that is A multiplied with E alpha delta T. So this is equals to E A alpha times delta T. This is force that is developed. So P equals to E A times alpha delta T. Cross sectional area we know, and then Young's modulus we know. Alpha is coefficient of thermal expansion, delta T is the change in the temperature, right? Coefficient of thermal expansion, change in the temperature. This is the force that is developed because of change in temperature. This is to be resisted by sleepers. If let us say one sleeper can resist a force of R newtons, R kilonewtons, whatever it is. One sleeper can resist a force of R kilonewtons or R newtons. Then total number of sleepers N. Total number of sleepers N equals to total force upon R. If one sleeper can resist a force of 10 kilonewtons, let us say this is 100. If one sleeper can resist a force of 10 kilonewtons, then total number of sleepers that should be provided is 100 upon R. Right? Then minimum length, L minimum. Then minimum length, so that there will not be any expansion. Minimum length, so that there will not be any expansion. L minimum on one side. L minimum on one side. If you ask me L minimum on one side, how will you calculate? If S is the spacing between the sleepers, or if number of sleepers is N and S is the spacing between the sleepers, L minimum would be equals to N minus 1 into S. On this side also, L minimum would be equals to N minus 1 into S. On this side also, L minimum is N minus 1 into S. On this side also, L minimum equals to N minus 1 into S. So if N is the number of sleepers, then L minimum equals to N minus 1 into S, where S equals to spacing between the sleepers. Center to center spacing between the sleepers. Fine. So S is the center to center spacing between the sleepers. L minimum is N minus 1 into S. Now what is the total length of long welded rail? Total length of long welded rail would be equals to L minimum plus central portion plus L minimum. Fine. So if central portion is 0, then it is minimum length of LWR. The minimum length of LWR would be equals to 2 times L minimum, that is 2 times N minus 1 into S. Fine. So central portion is 0 means that is the minimum length of uh, that means if that length is provided, like L minimum on this side, L minimum on this side, if 2 times L minimum you are providing, there will not be any expansion of the rails. All the stresses that is developed will be taken by the sleepers, so there will not be any expansion of the rails. Fine. If central portion is also provided, that means this is the central portion, right? This is central portion. Generally, there will not be any movement in the central portion or any stresses developed in the central portion. All the stresses will be developed is at the ends only. If they are saying minimum length, if they are asking minimum length of long welded rails, then it is 2 times L minimum, 2 times breathing length. What is the breathing length? Breathing length is the minimum length where the expansion of long welded rails can occur. That means indirectly the stresses can occur. So proper number of sleepers is to be provided over here in order to avoid the stresses that is developed, or in order to avoid the expansion of the rails. That is long welded rails. Any doubts in this? You can ask me. Any doubts? So the stresses develop due to temperature variation. The stresses develop due to temperature variation. Stresses develop due to temperature variation is generally taken by sleepers through fasteners. So sufficient number of sleepers So sufficient number of sleepers should be provided in order to avoid expansion joints. Fine. Next one is breathing length. It is the minimum length of rails. Provided on both sides in order to avoid expansion of rails. That means if you provide this much amount of length of the rails, then there will not be any expansion. No expansion means no stresses, or if stresses also developed, or if forces also developed, that can be easily taken by the sleepers. Fine, that is the meaning of it. Any doubts in this? You can ask me. Any doubts? Even the basic doubts, you can go ahead and ask me. So minimum length of the LWR in the examination they ask, that is 2 times L minimum. Please show rail joint, imagine if possible. Please, what is the meaning of it, guys? Show rail joint means there will be one rail, from here to here there will be one rail, and from here to here there will be another rail. If at all there is a joint, it would be something like this. If you see the cross section, just take this an approximation, not exactly the same thing. Fine. The rail will be from here, and another rail will be from here, like this. If at all there is joint, the joint would be something like this. Joint would be generally something like this. We try to weld it here properly. We try to provide the welding here properly. so that there should not be any problem of expansion over here. Sometimes bolts can also be provided. Between these two things, bolts will be provided. Like, there is one rail here, another rail here, bolts will be provided like this, connection of bolts, and design of weldings and design of bolts that you will see in your steel structures. Fine. So this is the thing. And Narendra, what is your doubt? Sir, how to define the central no movement zone? Central no movement zone means, central portion or central no movement zone means, here you are providing sufficient number of sleepers. You will provide more number of sleepers so that you don't worry, like, if you need 10 sleepers, you will provide 20 sleepers over here, so that you don't have to worry about the like expansion, contraction. After the central portion, you reduce the number of sleepers. You reduce the number of sleepers. You reduce the number of sleepers on this side. See, you can't provide more sleepers, right? So how much? So at least you should provide minimum number of sleepers so that there will not be an expansion or contraction. Sometimes, generally, what you do is we remove this no movement zone. We remove the central zone. We provide two rails, like L minimum, L minimum. We remove this so that sleepers on this will be same. Equal amount of sleepers will be provided. Generally in casual, but sometimes if you want to be more safer, then you will provide a central zone also. आपने बोल देखा, welding नहीं देखा. If you have not seen, I can't do anything. Go and see in the rails, in the new rails also, or in the metro rails also, you can see that there will be weldings. Bolts, if you are seeing, that is it's old rails. That's it. Generally, we don't modify the rails as frequently as possible. Any doubts up to here? Any doubts up to here? Please take a question. Yeah, please take a question. Determine minimum, determine the minimum theoretical length, minimum theoretical length of LWR beyond which the central portion of 52 kg rail would not be subjected to any longitudinal movement, due to 30 degrees temperature variation, centigrade temperature variation. Use following data. Cross-sectional area equals to 66.15 centimeter square. ES 2.1 into 10 to the power of 6 kgs per centimeter square. Alpha equals to 11.5 into 10 to the power of minus 6 per degree Celsius. Spacing equals to 60 centimeters. Average resistance force, average resistance force, per sleeper per rail. Average resistance force per sleeper per rail equals to 300 kgs. 300 kgs. Please try to solve this question. Please try to solve this question. You have also seen bolt joint. Generally you see that because our rails are very old rails. In the new rails you don't see that as frequently as possible. Sir, I am watching your previous. Hey, hi Kumar, how are you? I hope I am entertaining you, Kumar. I am watching your previous class of structures and highway. I must tell you, sir, you are definitely one of the best teachers in India. Thank you. Structure कभी समझ ही नहीं आया, पर जब आपका lectures देखा तो complete समझ आ गया. You are the best teacher. Love you too, rocker. I hope you rock the examinations. What is the answer, guys? Make it simple, na? .5 meters you are getting. Okay, whatever you get, give me that answer only. No issues. Do we have any issues? I don't have any issues. Ha ha ha. Narendra is getting 190.5 meters. What about the other guys? Only 12 people are watching. It's okay. Good evening, Bhaskar Tyagarajan. After a long time, I am seeing you. Kushbu ja clear. What is the answer, guys? Try to solve, make it fast. Everything is clear, it's just application of formula, right? So P equals to A E alpha delta T. So A is how much? 66.5 centimeters square, I think they have given. E is 2 into 10 to the power of 6 or 2.1 into 10 to the power of 6. Alpha is 11.5 into 10 to the power of minus 6. Delta T is 30 degrees Celsius temperature variation. This is 30 degrees Celsius. What is this value? P value will be getting in kgs. P value will be getting in kgs, right? P value will be getting in kgs. What is the answer? .5 multiplied with 2.1 multiplied with 11.5 multiplied with 30. So that is 48179.25 kgs. This is the force. And what is the force taken by single rail? That is 300 kgs. Single sleeper, okay? Number of sleepers equals to P upon R. That equals to 48179.25 upon R is 300. So what is your answer? Number of sleepers divided by 300. So that is equals to 160.59. Approximately you will provide 161 sleepers. 161 sleepers. If N is 161 sleepers, then what is L minimum? L minimum equals to N minus 1 into S. N is 161 minus 1 into S. S 60 centimeters. Spacing between the sleepers 60 centimeters, right? So 60 centimeters. This is equals to 160 into 60. That is 9,600 centimeters. 96 meters. Breathing length is 96 meters. Then minimum length of central portion length is not given to me. So minimum length of LWR, long welded rails, would be 2 times L minimum. 2 times L minimum, that is 2 times 96, that is 192 meters. Any doubts? Simple. So 192 meters means very huge. It's not like in kilometers it is less, it is like 0.2 kilometers, but yeah. So this is how you calculate minimum length of long welded rails. Any doubts in this? You can ask me. Oh, calculation mistakes. I am very much sorry if there is any calculation mistakes. Prachi. Any doubts? Okay, I did the calculation mistake, it's okay. Length of the rail is 13 meters. Long welded rail means I'll add. This I'll keep on weld it, so that I'll prepare 192 meters bigger length. Another 192 meters, and then I'll join both the things. So in this 192 meters, there will not be any expansion. In that 192 meters, there will not be any expansion. That is how it is made. Be clear, 13, you will join every 13, 192 bigger thing I develop. Another 192. These two things will be connected by bolts or welding, whatever it is. In this 192 meters, there will not be any expansion. In another 192 meters, there will not be any expansion. In another 192 meters also, there will not be any expansion. Due to change in the temperature, there will not be any expansion. That is the idea. Now, is it clear? Is it clear, guys? Fine. If I have completed that, next one is sleeper density. Sleeper density. Sleeper density. It is defined as number of sleepers. It is defined as number of sleepers provided for one rail length. One rail length means generally it would be approximately 13 meters or 12.8 meters, right? Approximately 12.8 meters. For 12.8 meters length, how many sleepers you are providing? That is called as sleeper density. It is given as n plus x. It is given as n plus x, where n is the length of the rail and x is the value. Okay, n is the length of rail. Generally it is 12.8 meters. If nothing is mentioned in the question, you will take it as 12.8 meters. If they mention 26 meters, you have to take 26 meters. If they mention 30 meters, take 30 meters. Okay, that is the idea. And sleeper density normally varies between n plus 3 to n plus 6. Sleeper density normally varies between n plus 3 to n plus 6. That means n plus 3, if I say 13 plus 3 is 16 or 13 plus 6 18. That is how sleeper density varies. Fine. Any doubts in this? You can ask me. Any doubts in this? Any doubts? No doubts? Fine. So the question is calculate total number of sleepers. Calculate total number of sleepers required. Calculate total number of sleepers required for 5 kilometer rail. Calculate total number of sleepers required for 5 kilometer railway track. 5 kilometer railway track. If sleeper density is n plus 5 for a broad gauge track. If sleeper density is n plus 5 for a broad gauge track, calculate total number of sleepers required for 5 kilometers railway track if sleeper density is n plus 5 for a broad gauge track. Okay, so please, what is the answer? Please give me the answer. The only path. Okay, clear? Thanks. Very huge, huh? Very huge. 5 kilometers length is also very huge. So just give me the answer. What is the answer, guys? So for one rail length, for one rail length, for one rail length, generally number of sleepers equals to n plus 5. He has given sleeper density as n plus 5, that is 12.8 plus 5, 17.8. You can't provide 17.8, so you will provide 18 sleepers. For one rail length it is 18 sleepers. That means for 12.8 meters you will provide 18 sleepers. You can't provide 17.8 sleepers, so you will provide 18 sleepers. Then for 5 kilometers means 5000 meters. What is the value? If I take this as x would be equals to 5000 multiplied with 18 upon 12.8. So what is the value? 5000 18 upon 12.8. If there is options, we can go for it. So there is no options. What is that you are getting? 5000 into 18 upon 12.8. 5000 multiplied with 18 divided by 12.8. You will get approximately 7031.25. So approximately you will give 7032 sleepers. 7032 sleepers. That is the idea. Any doubts? Any doubts? Any doubts? No doubts? Fine. Next one is depth of ballast cushion. Depth of ballast cushion. Depth of ballast cushion. How you are going to find out depth of ballast cushion, right? So let us say there are rails. I am showing you the elevation. There is rail over here, and there will be sleepers. And let us say there is sleepers. And there will be ballast. Center to center spacing between the sleepers, let us say this is S. Center to center spacing is S, and width is W. Width is W. If I take this as some S, this is W, this is W. If this is W, this is W, then what would be this length? This would be S minus W by 2, W by 2. So this would be S minus W. S minus W. Generally the effect would be like 45 degrees. The effect of rails would be up to 45 degrees from here. This is 45 degrees. Let us say this is also some 45 degrees. If that is 45 degrees, then what would be this depth? This depth would be, if this is 45 degrees, this distance would be S minus W by 2. If this S minus W, this is S minus W upon 2. If that is S minus W upon 2, this will also be S minus W upon So we assume, or as per the code, we will be taking this as the 45 degrees depression into it. This is ballast. So minimum depth of ballast cushion. Minimum depth of ballast cushion is generally given as this is ballast. These are sleepers, and these are rails. I am showing longitudinal view, not cross section. I am seeing the rails like this. Fine. So if you see like this, this is sleepers, this is rails, and if this is rails, and this is ballast. Fine. You are seeing the longitudinal view. There is a rail. Below the rail there are sleepers, and below the sleepers there is ballast. Ballast will be in this one also, but the minimum depth of the ballast is taken as S minus W by minimum depth of ballast cushion. Minimum depth of ballast cushion equals to S minus W upon 2, where S is spacing, center to center spacing between the sleepers. W is width of the sleeper. Center to center spacing between the sleepers. W is the width of the sleepers. So minimum depth of ballast cushion is S minus W upon 2. Fine. So any doubts in this you can ask. S minus 2W. No, Kushbu, it's not S minus 2W, it's S minus W. W by 2 here, W by 2 here. S is from here to here, not from this end to this end, center to center. If this is center, this is W by 2, W by 2. If I add, the whole thing would be W. So from here to here, it is S minus W. And this exact center would be S minus W upon 2, S minus W upon 2. So this distance will be S minus W upon 2. Right? So this is how you are going to find out depth of ballast cushion. If this is minimum depth that you have to provide, so that there will not be any problem. Okay, fine. So I wanted to start geometric design of railways, but I'll start it fresh tomorrow. It takes some 2 to 3 hours of time, so I'll complete geometric design of railways. Then only I'll leave tomorrow. Don't worry about it. Fine. So with this, I'm closing this session today. If you are having any doubts, you can go ahead and ask. If not, this is Karthik Mandalapu signing off. Good night. Yeah. I'll complete geometric design of railways, and after that there will be some points and crossing. That will be for another day. Good night. Bye bye.